the first day of GLEX will see 3 so-called high-level plenaries, and they are all dedicated to the topic, the future of space exploration. And to be sure that we are covering each and every aspect of this thrilling subject, we will invite on stage both representatives of agencies and governments, as well as representatives of the main industries that are active in this field. And this will allow us to cover both aspects, gaining a truly comprehensive look at what we can expect in terms of space exploration in the coming decades. But before we kick off this exciting program, let me share some organizational information. We always want to be sure and make sure that you, the audience, have also the opportunity to interact with our speakers, and therefore we point you to a platform which we are using. It's called Slido. You see it here on the screen behind me. That will allow you to ask questions during the plenaries. It will also allow you to upvote the questions of other participants. And of course, the questions that have the most votes will have a better chance to be answered by our speakers. So please scan the QR code, register, and don't be shy, ask questions. But now, it is my great pleasure to kick off this program by introducing the first of today's 3 plenaries, which is titled The Future of Space Exploration, the Agency Perspective, which I have the honor of moderating. And to start with, I would like to call up our speakers on stage, and it's my great pleasure to welcome on stage Dr. Josef Aschbacher, the Director General of the European Space Agency. Can take the first one. Then Mr. Kazuyoshi Kawasaki, Deputy Director General for Human Spaceflight and Exploration at the Japan Aerospace Exploration Agency, JAXA. Dr. V. Narayanan, Secretary of Department of Space and Chairman of the Indian Space Research Organization in ISRO, and of course our wonderful host for this conference. Next, Ms. Jill Smith, Director of Space Exploration Planning, Coordination and Advanced Concepts at the Canadian Space Agency. And last but not least, Professor Wu Weiren, Director General of the Deep Space Exploration Laboratory and Chief Designer of China's Lunar Exploration Program. Please. So there is so much one could say about space exploration as an introduction to this plenary, but I'm sure you all would be more interested to hear from our speakers, and therefore I would like to jump immediately into my questions to you. And my first question will go to all of you, one after the other, and that would be: space exploration has long been one of the most captivating elements of every agency's space program. What plans does your country or your agency have in terms of space exploration for the coming years? Maybe we start with Dr. Aschbacher.
First of all, I think this is really a question that drives us all. We have heard this morning from ISRO how inspiring exploration is for not only the space community, but the whole country. 1.4 billion people are getting inspired by incredible achievements which India has made in the last years. And I really would like once more to congratulate India for the huge successes you had and you still have in your pipeline for the future. Really impressive and very nice to see. So what do we do in ESA? Of course, also ESA is working on exploration since many decades, actually since the very beginning of the foundation of the European Space Agency 50 years ago. And we have a number of activities. But let me just highlight some of them and a bit the philosophy of what we had. First of all, exploration for me, for my member states, for ESA, is a top priority. And I'm not saying it because we are here at GLEX, but I can prove it with numbers. We had a very significant increase of our budgets of the Exploration Directorate or the Exploration program called Terra Nova in the last ministerial. And we are preparing today a very, I would say, ambitious package again. This is under the leadership of Daniel Neuenschwander, who is here with us, who is actually quite active in putting with his team a very good proposal together and discussing it, preparing it with our member states. I see Germany just walking in when I talk about our member states as a key player also in exploration, but together with all the other ESA member states. So this is really something we do since a long time. So what are our priorities? Of course, ISS participation since the very beginning. We are one of the key partners of the ISS. You all know who they are, but the European Space Agency is one of the main ones, and there we have been incredibly successful in doing experiments and doing work on the space station, and as for more than 2.5 decades now, and this is really something that is a top priority and will continue. Of course, the future will bring commercial space stations, and we are already in very close discussion with the various actors who are preparing right now their commercial space stations for the future. In addition, of course, if you go from LEO, and LEO has both components, the experimental part and obviously the human part with the astronauts, but then we go towards Moon. There we have, of course, an active program with a number of activities. We have participation in some, I would say, smaller lander programs where we provide some contribution. But our bigger contributions are called Argonaut, which is a vehicle that transports infrastructure from Earth to the moon surface, about 1.5 tons of payload. And this is in construction, in development right now. And in addition with or Moonlight, or I would say as a complement as a complement to Argonaut, we have Moonlight. Moonlight being a constellation, a future constellation for telecom and navigation around or on the moon surface and around. So again, there we are investing, building up the moon economy. Of course, we are in very early days on this, but certainly building blocks which we have. Of course, we are a very strong participant in the Artemis program. We have the major big contributions to the Gateway. We provide the European service module that brings astronauts around the moon and eventually to the moon surface. Of course, this is done with NASA. As you all know, there are budget discussions taking place right now. We will commit on our side to contribute what we have promised. We have always been a reliable partner, and we will continue to do so. If things change, of course, we will need to adjust, and we will be ready to do that, always in consultation with our member states and see what proposals we would eventually make. But certainly we are committed to move up our activities on the exploration of Moon and of course the low Earth orbit. Then we have Mars. Mars is the next destination. We have the DGO and ExoMars missions, which are being developed, which are a reality. We plan to launch the Rosalind Franklin rover in 2028. This will be quite an exciting mission because it will be the very first one taking a probe under the ground of the Mars surface and analyzing it on the surface of Mars, especially for traces of life, past life, or maybe even existing life, we do not know, but certainly of traces of life. And we're going 2 meters underground, and this is where exobiologists are saying you have to go because on the surface you would not find any traces of life. And of course, again, there we have a number of activities that we are building up. Lightship is another new idea that is being conceived right now with our member states and see how we could use that as a transport vehicle for future activities on Mars. So yes, there's a lot to be done. LEO, Moon, Mars is our focus. Budget-wise, we are gearing up. We will prepare a very important proposal for the ministerial in November, of course, to be decided and subscribed by our ministers in Bremen. But I am pretty sure that this is something that finds wide support because exploration is such an important topic.
Well, thank you very much for this very comprehensive overview of this solid exploration program of the European Space Agency. Thank you. Let us move on to JAXA. What's in the plan?
Yes, thank you very much. JAXA, as a core agency for aerospace research and development in Japan, we have studied so many technologies to be needed in future exploration and recommended them to the government. And finally, we got agreement, the Artemis Accord, that the Japanese government signed up in 2020. But I'd like to stress that the importance of the internal cooperation, because we have participated in the ISXG since 2007. So ISXG is an international cooperation, international space exploration coordination group. Currently, 27 agencies participating in this. For so many colleagues participating in, and we have shared some roadmaps of each agency's plans, and most important thing is sharing the future vision for the exploration around 2040, like Isa said. And they summarize that GER, Global Roadmap, Exploration Roadmap, GER, was published last year, chaired by Isa last year. So thanks again to the Isa that activity that challenge to that documentation. And also the GER is a very important tool to discuss with our government, because we have 18 years history to the ISXG. So this is so easy to communicate the importance to our government, to the importance of the exploration. And also we have published that Japan, JAXA has also our own space exploration scenario in 2017. And we are now revising it in 3 or 4 years. And currently the newest version is being revised, reflecting the newest conclusion of the missions, or some studies from the architecture to build a moon base for the future. So our vision is to create a human presence, permanent human presence in around 2040, and in a sustainable manner. So in this scenario, so we have 3 major missions written in this scenario. First one is SLIM, which was already done last year, successfully landed on the moon, soft landing. It is a very precise manner. We call it pinpoint landing within the 100-meter accuracy. And the next one is very step is Lunar Polar Explorer, is RUBEX, just Chandrayaan-5 RUBEX project, and in collaboration with ISRO. And we are going to search for the water ice existence in the moon solar polar region, and we have determined the amount and the quality of the water. And we have had an agreement with ISRO, and ISRO will provide us a lander, and we will provide a H2 rocket and also this rover we call the RUBEX. And after that, using this technology and measurement of the result, we are going to search for the moon polar region survey and make a permanent human habitat in the future with Israel or other countries. And also we are going to developing a lunar rover, pressure rover. We can operate this rover with human and about more than 10 years around the southern polar region. So that is the plan right now.
Thank you very much, Mr. Kawasaki, especially also for making the point for international cooperation through ISAC and bilateral or multilateral agreements. This is something that is also very close to the heart of the International Astronautical Federation. We want to provide a platform to be able to set up new cooperations and partnerships. Next, please, Chairman of ISRO, Mr. Narayanan, please. What's up? We've heard already a lot, but maybe you can give us an overview again and go in more details.
Thank you. Space exploration holds a profound intellectual significance in India's space journey, inspiring millions of youth. You all know space activities in India started in the year 1962, And we started with 17 rocket program. In fact, till we had our own launcher, up to 1980, we had the successful launch of the launcher, first launcher SLV-3. Up to that, we were continuing the journey with lot of sounding rockets. And we were studying the atmosphere, ionosphere, cosmic rays, all those studies were done up to that point of time. Then, of course, we entered into the development of the launch vehicle area, and SLV-3, ASLV, those were experimental vehicles. Then came to the PSLV, GSLV, and LVM-3, and of course, today, 6 generations of vehicles are developed. After these launch vehicles came, in fact, the space exploration activities went in a very big way. And Chandrayaan-1, that was the first interplanetary mission, and you all know the Chandrayaan-1 mission found water molecule on the moon and made the entire global community so proud to understand the water molecule on the moon. Also, I have to tell one of the aspects of the Chandrayaan-1 mission. For the first time, a moon impact, even though it didn't add great scientific value, it added a lot of value to us. The moon impact probe, first time, our tricolor was placed on the moon. Then, of course, we moved on from that to Chandrayaan-2. Chandrayaan-2 is supposed to be, it has to get a lot of objectives. Of course, we had to take it to the moon surface, then we had to have a soft landing, but soft landing we could not accomplish. It doesn't matter, but we are having a really a orbiter, which is having a high resolution. In fact, there are 8 payloads, and which has given a lot of scientific data. And the on-orbiter high-resolution camera, which is having a resolution of 32 centimeters, is the best camera, as per my understanding, in the moon's orbit. Actually, the data are so good. Not only that camera, and the remaining payloads data are also so good. Then coming to the next one, the Mars orbiter mission. Of course, we have gone to Mars, and for the first time, we could succeed in the first attempt itself. And that itself was a great satisfaction. But then, the type of wealth of data which has come from that mission, including the Martian surface, marbology, and there are the indications of even hydroxyl molecules. Lot of discovery has happened through the Mars orbiter. Then coming to Chandrayaan-3, in fact, I will say it was a very exciting mission. And 23rd August 2023 is a great day for the entire country. Why? It is not only for Indian, I will say that it is an entire global community, it is a big day. For the first time, a soft landing near the south pole of moon, and then taking lot of data from the south pole of moon, including discovery of number of minerals. And our rover, when it came out and moved, there are places we have understood seismic activities there. Then electron clouds discovery in the appropriate locations. Then the thermal profile. In fact, we carried a sensor with almost 10 temperature sensors, and then the probe went inside the surface. And quite surprising, there were a lot of thermal gradient from the surface to even 10 centimeter depth. So we have discovered all these things, and one good thing is, unlike the old days, people will discover and keep it with them. But here, everything we have shared with the international community. Then, of course, we had a AstroSat mission, and that was another important mission we have got, and a lot of wealth of data has come. Then coming to XPOSat, X-ray polarimetric experiment. This is another important mission. Now then, last year, 2023, the Aditya L1 is the satellite, which we had to really travel almost 15 lakh kilometers and commissioned in the L1 point. L1, you all know, it is an imaginary orbit. So we have to commission, and perfectly commissioned. And then, if you look at the data after 1 year, this year, January 6th, we were looking at the entire collected data, and we have disclosed the entire scientific community. And lot of almost 5 terabit data we have disclosed. And the second data set released was on February 14th. And one should see, actually, unless you see the video, you cannot appreciate the mass ejection from the lunar surface. The video, when it was reported to me also, okay, some mass is getting ejected, that's what I was feeling. But when the video you see, you get a different feel, how the mass is there and how it get dislodged and what is the type of area it is influencing and so much of activities, and this is done. Now coming to the, if you take the, rather that Chandrayaan related continuation mission as it was addressed, today we are going to have 2 more missions. Chandrayaan 4, already you have seen the model. It is going to be a sample return mission. And Chandrayaan 3, the total satellite mass is close to 4,000 kg, 3,913 kg if I am correct. But here it is a 9,600 kg satellite. And just for a comparison, Chandrayaan 3, the landing unit, it was something around 1,600 kg. But here it is going to be something around 6,800 kg is going to be the landing mass. And so a lot of things are happening. And of course, the sample return has to happen. Sample return means then a lot of docking, docking has to happen, docking and de-docking. At least 2 times you have to dock and 3 times you have to de-dock, all those things. And through the SpaceX, we have done all those experiments. And then that mission, in fact, we are working towards that mission that is on. And slowly, this is going to give lot of data in terms of, even though till today, something around 300 kg sample is brought back and a lot of discovery is done. We are confident, so many research happened and then we could find out water molecule. Similar way, we are expecting a lot of outcome from that mission. We are going to put appropriate payloads. Then LUPEX mission. LUPEX mission is a joint collaboration. I am extremely happy that we both are working together. And then it is a very, very important mission. And Chandrayaan 3, the lifetime was only 14 days. But here we are going to have, my understanding is correct, 100 days is going to be the lifetime. 100 days means you can understand lot of wealth of data is likely to come out of that mission. And again, it is the rover, for example, in Chandrayaan 3, the rover mass was hardly 250 kg. But here the rover mass is going to be something around 350 kg is the rover mass, more than 10 times is the rover mass. And then it is a joint collaborative effort, and I am sure a lot of result will come out, and towards that lot of development has to take place. You know, so to have such a landing thing, including something around 6 ton, we have to land there on the surface, and you need to have new propulsion systems. A lot of work has to be done, and precisely you have to land. And then all those works are going on. And the culmination is, Honorable Prime Minister has given a clear direction. We have to have a crewed moon mission. And crewed moon mission means solely when you take through the robot a lot of sample versus when somebody goes there and then try to understand. That has a different feeling. And that we are working on that. Now further, if you see Venus orbiter mission. Venus is another interesting planet. In fact, that atmosphere, temperature profile, everything is totally different. And that we have got the approval for the Venus orbiter mission. Then Mars, earlier the mission was only a Mars orbiter mission. Now we are working on the Mars lander mission. This also the work is going on. So thereby, in fact, in the area of space exploration, our hands are full. And one very good thing is, whatever data we are going to receive out of all this mission, we have taken a call that everything will be shared with the international community. Because when we talk about the single family, simply talking alone is not adequate. We have to prove ourselves. So this decision we have taken, like Chandrayaan 3, whatever we shared, same way we are going to share the data. Thereby, I am very happy to inform this august audience that ISRO is having a very vibrant space exploration activities. Thank you.
Well, thank you very much for this outline of all the outstanding successes. Let me just remind everybody that Chandrayaan 3 indeed was such an outstanding mission that the International Astronautical Federation has awarded its highest award last year to Chandrayaan 3. So once again, congratulations, and of course, exciting to hear what your plans for the future are. Let's move on to Canada. Ms. Jill Smith, please.
Thank you. There we go.
Yeah.
Thank you for inviting me. It's a pleasure to be here at GLEX in India. It's really an honor to be here as part of this panel to talk about the Canadian space program. You see on the slide some of the major activities that are going on currently in Canada in space exploration. We have many missions and initiatives in operation right now. We have Canadarm2, which has been operating on the International Space Station for close to 25 years, and just recently it performed its 50th free flyer capture, and this is something that was not even designed to do with Canadarm2 in the beginning. So it really shows the versatility of the robotics operations that we're capable to do. We're also using the ISS in terms of science development. We're focusing a lot on health and medical research. So this is great activities. We do have Canadian elements on the James Webb Space Telescope, which continues to operate and keeps wowing us with amazing pictures and discoveries of the cosmos. In the near term, we are looking forward to receive the Canadian portion of the asteroid samples from Bennu. So that came from the OSIRIS-REx mission. It will be stored in our clean room that we're currently building at the CSA, so we are receiving them next year. This is really a remarkable opportunity in space exploration because it will give the opportunity for researchers for now, but also in future generations to work with this very unique material. So we're really looking forward to that. In terms of the lunar portfolio, we are a partner in the Gateway program. We are following very closely the budgetary decisions that are being made right now in the US, but continuing to work on Canadarm3 and advancing our robotics expertise and capabilities in Canada. But we're also investing in mobility for the lunar surface. We have a small science rover, and we're also developing a larger lunar utility rover that will support various activities on the surface. And we're also exploring various concepts development for the future. As part of lunar and Mars exploration, we're looking into, for example, power generation and distribution. We're looking into communications. We're looking into ISRU. So we see those as fields of the future that we're interested in investing in right now. So those are concept studies. We're doing some architecture studies, but hopefully we'd be able to progress on those as well. We also have a core of astronauts who are training, or Jeremy Henson is training for the Artemis II mission. We have Josh Kutruk, who's training for a long duration stay on board the ISS. And we're also looking into how we want to continue to use a LEO post-ISS. So this is also a major activity that's going on right now. I'll close by saying, so if the CSA reports to the Minister of Industry, Science and Innovation. So everything we do involves the Canadian space sector and in industry and in academia as well. They're really key to help us achieving the goals that we're setting for ourselves in Canada. And we have a lot of work ahead of us, and hearing what the partners are doing as well. Of course, international collaboration is key into delivering everything that we do. So thank you.
Thank you very much for giving this overview on this manifold different aspects of Canadian space exploration program. Last but not least, Professor Wu, if you could let us know what China's exploration program has in stake for us.
谢谢主任，我用中文说，为了准确的表达，我用中文说，然后我的同事翻译成英文。
So Professor Wu will speak in Chinese and we will translate.
中国未来10年应该是航天大发展的时代。我主要讲一下我们国家未来10年的深空探测。这深空探测里面呢，一是月球探测，二是行星探测，三是小行星探测。
So in the next 10 years, will be a big program for China aerospace development. And this is one inside we are focusing on the deep space exploration. For the deep space exploration, it will be the three parts. First one is the lunar exploration. The second is planetary exploration, and the third one is the asteroid exploration.
在月球探测方面，我们主要是3件事：一是我们明年将发射嫦娥6号，实现在月球南极着陆，并且呢，能够在月球南极的深坑里面去探测水存在的证据。同时呢，我们2029年左右发射嫦娥7号，也是着陆在月球南极，主要是月球资源的科学考察和月球资源的利用。
So it's for the lunar exploration. Is also three of the different major missions. The first one is Chang'e mission, the Chang'e 7 and the Chang'e 8. So it's Chang'e 7 will be launched in the next year. So it's will be land on the south pole of the moon. The purpose is will be to find the direct evidence of the ice water on the south pole. And for the Chang'e 8 will be launched before the 2030. Maybe around 2029 would be to have the basic structure of the lunar base will be established, including some power system and the communication system.
在月球上的第2件事呢，是我们争取2030年前后实现把中国人送上月球。
The second major mission is we will try to send the first Chinese astronaut landing on the surface of the moon before 2030.
在月球上第3件事呢，是我们已经和17个国家联合签署了协议，还有50多个国际组织。我们希望在月球上建设一个月球国际科研站，这个站址呢就选择在月球南极。
The third major mission is we already have cooperated in the global more than 17 of the countries and the international governmental organization, and also more than 50 of the international academic institutions to jointly to build International Lunar Research Station. The purpose of this International Lunar Research Station will be to build a permanent station. The lunar base will be on the south pole of the moon.
在深空探测的第2项工作啊，就是行星探测。我们现在正在研制天问3号，希望是在2030年前后实现在月球上在火星上采样返回，争取我们现在已经开始在建设火星地面实验室。
So for the planetary exploration, the first one is the Tianwen 3, which the purpose will be take the samples, Mars samples from the surface of Mars and return back to the Earth. So we would like to launch it around 2028, and it will be returned back around 2030 or 31. So we already start to build the planetary sample laboratory in China.
同时我们正在研制天问4号，天问4号将实现对木星及其木星系的探测，探测过后呢，然后呢我们转身对彗星的探测，这个是更远的探测了。
And the next mission will be called the Tianwen 4. The Tianwen 4 will be to launch around 2030. The purpose is this mission is to exploration for the Jupiter and his satellite, and after the exploration of the Jupiter will be to exploration to other comets. So this is a further deep space exploration.
在深空探测第3个方面，我们主要开展是小行星的探测。今年5月底，我们将发射一个天问2号，实现在4000万公里的地方对一个小天体实现采样返回。
The third part of the deep space exploration is asteroid exploration. Just at the end of this month, we will launch another mission. It's called Tianwen 2. The purpose of the Tianwen 2 it will be fly to the one of the near-Earth asteroid, which is 40 million kilometers away from the Earth. We will have some exploration and take the sample from this asteroid and return back.
在小行星探测方面的第二件工作呢，就是我们国家将建设小行星这个防御系统包括那个地基的天基的，以防小行星撞击地球造成严重的威胁。所以我们要构建这么一套系统，争取人类为人类做出一些中国的贡献。
For the asteroid exploration, the second mission is about the near-Earth asteroid defense. So China will consider to establish one of the whole of the system, which is on ground and also on the space. So this is a system will be avoid the damage will be caused by the pack of the near-Earth asteroid. So this will be system to defense of the future damage of the asteroid.
在小行星探测方面，第三件工作就是我们正在酝酿，中国科学家提出来，准备在2027年左右实施一次小行星在太空拦截，改变它的轨道。这个小行星我们选择30米到50米直径的，可能是潜在威胁地球的这么小天体。我们希望能够在太空对它进行动能拦截，改变它的运行轨道，以3到5个厘米每秒。
So for this purpose, that we would like to make a demonstration mission around 2027. We will choose one of the near-Earth asteroids, which is a diameter around from the 30 to 50 meters, where we have the dynamic impact to this asteroid and light them to change its orbit about 3 to 5 meters per second.
这是中国未来几年的在深空探测方面的3个方面的工作。我刚才简单归纳一下，我觉得在乐器方面我们要干3件事情，在行星探测方面我们干3件事情，在小行星探测方面我们也干3件事情，加起来9件事情。
So this is totally the 3 part of the China deep space missions in the next 10 years. So for every part will have 3 missions. For the lunar mission, for the lunar part will be 3 missions. The planetary exploration part is a 3 mission, and for the asteroid exploration mission also the 3 missions. Totally 9 missions.
在这些工作中，我们都希望和全世界航天界的，包括印度、日本，包括我们现在在座的这些国家，我们一起共同合作。
Within each of the mission, we welcome the international cooperation with all of the countries, especially the country we have today, the European, the Japan, the Canada, Israel, to participate into those missions.
好，谢谢。
Thank you very much.
Thank you very much for this very comprehensive outline of China going to the moon, Mars, asteroids. Let me just jump back. One mission, Chang'e 6, that was an exciting one, and we from the IEF were so happy to have the opportunity at the last IEC also to get to showcase with your help the samples of Chang'e 6. And I need to make a short announcement here that the IEF has also selected Chang'e 6 as the winner of the 2025 World Space Award, and that will be awarded at our next IEC in Sydney later this year. So we look forward to that. Thank you very much. I would like now to go into individual questions and dive a bit deeper, but I would like, in the interest of time, ask you to stay maybe within 3 minutes for your answers. Start with Dr. Aschbacher. You've just kind of published your ESA strategy 2024, and I've taken it with me here. Could you please outline a bit what the major elements are with respect to space exploration in this strategy?
No, thank you. I will stay to 3 minutes. So this is the strategy. Very warmly welcome everyone to download it. But let me focus on a few things that are particularly related to international cooperation, and IAF is, of course, the body who is fostering international cooperation, and GLEX is here a very good body. Goal 1, which deals with protecting our planet and our climate, will continue, and I talk of a 2040 time frame because this is the time frame of the strategy. We will continue to have a major Earth observation program looking at our planet from all angles. We have 12 Sentinel missions flying by then. We have 6 families today. We're adding another 6 in the years to come. And there will be certainly, I would assume, it's probably one of the leading Earth observation systems to really look at our planet from all different aspects: atmosphere, land, oceans, cryosphere, and their interactions. In addition, of course, protecting the planet, and we have just heard it before from the Chinese colleagues, we will plan missions also to protect our planet. We have Ramses in the making that will be encountering Apophis, an asteroid coming to planet Earth on Friday the 13th, not joking, April of 2029. And we, together with international partners, are defining a mission to do that. I really would like to mention Japan as a major partner in this to have the Ramses mission coming. The next one is explore and discover. This is about science and exploration. I've already mentioned a few elements in my speech before, but again, this is international. And there we, as Europe, we really want to be a good partner. And if I look in 2040 as a time frame, I'm pretty sure that the lunar economy will be developing very well by then, that Mars will be explored by then, and there we have a number of missions already in the pipeline today. I mentioned them already, but certainly for me, as ESA, this is the focus of international cooperation, where we have many partners with whom we already work today, and I would like to strengthen that and to really have a wide global activity here, which we need in exploration, because this is so big, it's so important that we need to join forces. Then we have activities related to European autonomy and resilience. This means that we build up our capacity to be able to deliver satellites into space with our rockets, but also to provide and collect information and develop basic technologies that are needed in order to develop these future missions. And some of these exploration missions where we need to build up our capacity are long-term missions in space science, for example. You mentioned, Jill, you mentioned James Webb Space Telescope. We also partner together with Canada and NASA on this mission, but we have also big other missions, either flying, Bepi Colombo together with Japan, the Euclid with some partners, JUICE with some partners, but new ones like New Athena, which will be the large new mission on the side of Europe, and possibly by 2040 we will have a mission development going to Enceladus, looking for traces of life on one of the icy moons of the outer planetary system. Then, of course, inspiration is always there. There we work together internationally with our astronauts. I'm very happy to see quite a number of here, but it's not only astronauts, it's also education, it's exchange of data, exchange of information, training the kids, and really exposing them. There we will like to launch a number of programs, sometimes with partners, sometimes within the European context, but certainly a top priority. I hope I stick to the 3 minutes.
For sure. Thank you very much. I mean, it's very great to hear that exploration is so strong focus also in this strategy. And what I hear all here, I think is just a lot of outstanding topics for filmmakers to do outstanding movies for the general public listening to all of you. Now, let's come to JAXA. Regarding JAXA's efforts towards sustainable lunar exploration, could you tell us about the achievements so far and what the future plans in this respect are?
Yes, I think that there are 3 concepts for the sustainable exploration. One is a technological point of view. So we need some technologies to make a human presence permanently on the moon, like a habitat system or mining, what kind of agricultural system. Everything is needed to human presence. It's important because it costs about $1 million per kilogram to send to on the surface of the moon. It's too expensive, so we need to live there using ISRE techniques, something. So, and the second point is political commitment. Sustainable political commitment is very important, including international partners. Cooperation is very important. So we have some problems. Past we have also I have the experience in the International Space Station program. We have some problem we have, but because of the international collaboration, we can overcome that problem. So the second one is important. And finally, we did an important thing is the collaboration with the industries. I'd like to say collaboration with non-space industry is important. Like Lunar Pressure Rover, we are working with the Toyota motorcycle company. And they are not a space company, but they're very interested in that project because the technology that through the gains of that project can be returned to here on Earth. So already our project affecting that economy here on Earth, so the connection between the space non-space industry for the exploration is very important. So we are going to do this kind of project making right now.
Thank you very much for this plea for sustainable lunar exploration. Let's come to India, Dr. Narayanan. India has been pursuing a space program with an objective, in the first instance, of course, to bringing the benefits of space technology to society and for national benefits and development, of course. But you have also achieved tremendous achievements already in space exploration. Could you highlight one or two key successes of ISRO in the recent endeavors in space exploration?
Key success, I think I can share a couple of things. Now, you know, the docking experiments, we all understand when we are going for huge programs like crewed mission to moon. Surely one can have a big rocket and the requirement is something around 125 ton is the type of mass you have to lift it to low Earth orbit. But then if you develop such a rocket, what is the use of such a rocket after that? So we have debated and decided we will not do that. We will lift 2 modules and dock in the space and accomplish the mission. That means docking is a mandatory requirement. And of course, Chandrayaan 4 also I already explained docking is required. So keeping all these things in the mind, we mounted a program and SpaceX program. We lifted up 2 satellites last year, December 30th, placed in the orbit. But then 2 satellites are rotating with a velocity of 28,400 km per hour. Even we can understand, I think as a layman, one can understand if the 2 cars are moving on the road with 100 km per hour velocity, with relative velocity can be less, but then how to dock with a set of algorithms, cameras and systems. It's very, very difficult to imagine, but in the space, this has to be done in an autonomous way. And in fact, first time when we tried to dock, honestly speaking, we could not succeed. We had to make 3-4 attempts. And even though we had a simulator doing a lot of things, then finally, when we had a docking on 16th January, it was so exciting. It was not a perfect docking, I will say, but it was docked. And then through that system, we cannot really transfer the power from one satellite to another satellite. Then we studied perfectly, did a lot of simulation. At least thousands of simulations were carried out through a simulator. Then we de-docked the system on March 13th, if I am correct. Subsequently, we went for the second docking. Second docking, I have to say that it was done like a child play. Through a set of systems, it was perfectly done, and the power transfer was also done. And then, of course, we have also now de-docked. And another important experiment what we could do is the circumnavigation. That is one satellite rotating over the another satellite in manual mode and auto mode. It was so satisfying mission. And happy to report to this audience that we accounted 10 kg propellant. Each satellite 5 kg propellant for this purpose. And we have completed the entire mission objective with 50% of the propellant. Right now we are having 50% left out. I think it is our imagination, we can do a lot of experiments. That is one of the recent achievements. Another one, when you go back to the Aditya L1, I think the project director of Aditya L1 is here, Nigar Saji. You know, when they started building the satellite, originally, if my memory is correct, the satellite mass is supposed to be 1,450 kg maximum. But when they started building, the satellite mass went to 1,520 kg. And the PSLV vehicle is the vehicle already fixed. Now, I was put as the Mission Readiness Review Committee chairperson. where we have to review the satellite, launcher, ground segment, and finally we have to give the clearance. So before the meeting, one day I called the project director, I think he's here, Nigar Saji, can you explain what is the propellant margin available in the satellite? Because we have to travel almost 15 lakh kilometers, commission the satellite, and then the satellite has to work, design life was 5 years, and then she was telling only 10 to 12 kg propellant margin is there. Please understand, when the launcher places the satellite with some dispersion, which is a little beyond expected level, and you have to travel first time 15 lakh kilometers and commission the satellite in L1 orbit, I was not confident on the success of the mission, to be frank. Then we had to build a lot of margin, propellant margin has to be built. What we did was one approach. In the PSLV rocket upper stage, generally we keep something around 45 kg guidance margin. We slashed down to minimal level. So that we built margin. Then the entire the trajectory we revisited, tried to optimize. And finally, I am happy to report that we have gone successfully, commissioned the satellite. Today, I think the life of the satellite with respect to propellant availability is more than 8 years. So it is a highly satisfying mission. Not only that, the entire payloads have worked as I told, and we are getting wealth of data. Till now, 5 terabit data is rolled out. And Chandrayaan 3 is really a little different game. Chandrayaan 2, we could not succeed in soft landing. Now, then we are going up to 3 years for the Chandrayaan 3. You know, the type of tension you can have. And in fact, a committee was constituted to understand what are the improvements. I happen to be the national committee, that committee I was chairing. And we have given 107 recommendations from Chandrayaan 2 to Chandrayaan 3. And everything is implemented, and we are going for the second attempt. Second attempt, you know, if you don't succeed, what will happen, you know it. In the country, we cannot face even our own life partners, we cannot face. That is the situation. But then we were doing a very systematic job. We improved the propulsion system, improved the lander systems, and hazarder. We had the Chandrayaan 2, the camera, using that the entire area was nicely mapped. We understood which are all the right locations to land. Then it was really a tensed movement. August 23rd morning, the spacecraft is rotating with 6,077 km per hour velocity. And added to our tension, 10 days before, you know, historically, again, another country tried to land, and well-experienced people, and then they could not succeed. Then that put additional pressure on us. And then, we did all simulations, extensive simulation studies were carried out. Then we were going ahead. In 19 minutes, all the 3 parameters, the horizontal velocity, vertical velocity, and altitude, all the 3 made near to 0. And generally, there is a statement, Indians are credited with discovering 0 in the earlier days. That day, all the 3 parameters simultaneously making a 0 and soft landing. That was a very, very exciting time. And not only that, another tensed moment I would like to say, probably I don't know you are all aware. Yes, it has successfully landed. Now the rover has to come out, and rover is not coming out. And for 1 or 2 hours, it is not coming out. Maybe command is going, and we were worried whether command is going, received, all these things. Finally, you should see when the rover coming out, the scene you should see when the power generation is happening. It's such a golden bright color. That scene, unless you see, you cannot enjoy that. So exciting scene. And then rover coming out. It was so exciting mission. So like that, I think I can share a lot of things. I don't want to dwell further. Already time is going out. So it was a very, very interesting and exciting, challenging period. In fact, I want to share one thing, supposed to be confidential, but I can share. Chandrayaan 3 day, before landing, I got a phone call from my permanent boss. The statement made was, without success, don't come back to the house. This was the statement made. And you can understand this was the statement to most of the people. And it was a great, exciting day for all Indians and all the scientific community across the globe. Thank you.
Yeah, space exploration is indeed a very challenging area, of course, and everybody needs to show successes in order to keep the support of the government, of the general public. So congratulations to all these success stories. For Canada, international collaboration has always been at the core of the Canadian Space Agency's activities in space exploration. Can you tell us what lessons your agency has learned from the work with international partners and how this has reshaped how you approach partnerships and collaboration in space exploration in the future?
Yeah, thank you for this question. International collaboration is indeed part of our DNA in Canada. We do most of our portfolio of activities with international partners, whether it's in Earth observation or space exploration or all the activities that we're doing. It was mentioned this morning, we are a cooperating state of the European Space Agency. This allows us to connect the Canadian space sector to unique opportunities in Europe, and that has been a very successful partnership for us and for Europe as well, I hope. We are collaborating with partners, whether it's in planetary science, astronomy, human spaceflight as well. And I guess the key that we see to partnership is the diversity from ideas that we can gather when we work with other partners. It really gives us more opportunities to learn from the risks and challenges from the harsh space environment, and it allows us to adjust our own methods, our processes, and to work better and faster. So we continue to be a reliable partner. We deliver on our commitments, and our collaboration approach has been extremely successful in the past. And it will still guide us through the various opportunities and challenges that space exploration has in the coming years. Thank you.
Thank you very much. Now, last but not least, also a question to Professor Wu. You have mentioned before the International Lunar Research Station, ILRS. This is a huge, large-scale international scientific initiative led by China. What are your expectations for the future development, construction, and international cooperation on this project?
Thank you.
中国过去参加过很多国际大科学计划和国际大科学工程，但是呢，中国自己从来没有主导或者第一个提出过这种大科学工程，所以我们这次提出在月球南极建设国际月球科研站，这是中国主导或者提出的第一个大科学工程，我们国家领导人和我们整个中国的航天界都高度重视。
In the history that China have participated a lot of the international large-scale scientific project or large-scale scientific engineering project, but they have never have initial and lead one of the international large-scale scientific project. So International Lunar Research Station, the IRS, is the first the large-scale scientific project what is initial and led by China. Therefore, there's national leader and also all of the China space industry have paid a lot of attention to this is the international cooperation.
所以我们提出在月球南极建设一个长期无人运行、短期有人参与的这么一个工程，主要要实现月球的长期月面可考，就是科学考察、月面资源观测、资源利用。 还有日地环境、地域空间环境的考察这方面等等一些科学目的的一种工程。
Therefore, the purpose of International Lunar Research Station is to build up the permanent space base on the south pole of the moon. That will have the long-term the robotic and the short-term the involved with the astronauts. So could be have some of scientific survey, have some of in pseudo lunar resources utilization, and also will be exploration of the environment between the sun and the earth and the lunar and the earth.
我们希望能够在月面上建成有长期的极端恶劣情况下的能源供给，包括月面通信。 以及我们能够在月面盖房子，在月面可以打砖，是吧？可以资源利用，等等这样一些功能。
We hope that this station will have some functions, like have a power supply, have the communication system, could we have the habitat conditions, could we have some of the construction on the surface of the moon.
这月球是全人类的，所以我们建设这个月球科研站呢，也希望世界各个国家的科学家都可以参与。目前呢，我们是有这么一个打算，我们希望能够有50个国家，有500个科学研究机构和5000名国外的科学家共同来实现这个目标。
The moon is belong to all of the human being. Therefore, we welcomed all of the scientists in the world to participate. So we have some expectation in the next 10 years. We would like to invite more than 50 countries and international organizations, more than 500 international academic institutions, and more than 5,000 scientists research to participate into the International Lunar Research Station.
这个合作的方式可以是多种多样的，比如说科学仪器的研究搭载、科学数据的共同研究共享，包括我们测控通信，这些一方面的合作，以及我们从系统级、分系统级、单级都可以合作。
So cooperation could be the different way that it could be the scientific payload, the piggyback that we already have made on the Chang'e missions. Could be the joint the scientific data study. Could be some for cooperation on the system level, subsystem level, equipment level.
这方面我们对全世界开放。我们欢迎大家，包括今天在座的，也包括我们印度的朋友们，一起参与这个国际月球科研站。
This is a cooperation is also open to all of the world. Every country can apply to join this cooperation. So we welcome that all of countries will today and others countries and also especially the India partners to participate into this cooperation.
同时，为了配合这个国际月球科研站的对国际上的开放，我们中国有20个科学家，再加上国外30个科学家，以及有5个国内外的科学组织，我们发起成立国际深空探测学会。这个学会呢，经过长时间的完善过后啊，最近中国政府已经批准了。
To facilitate this international cooperation, so the China have initiated. We have organized about more than 50 of the global famous scientists, and also the 5 of the international organizations. We have initiated and established a new international academic organization. It's called the International Deep Space Associations. So this is the association will be headquartered in China and already approved by Chinese government.
这个学会的总部设在合肥，分部设在北京。到时候我们希望以后还加入到国际宇航联合会那个麾下。
So this is an association have the headquarters in the Hefei, China. And also we have subsidiaries in Beijing of China, and also we have more other subsidiaries in the different countries, like Europe. And this association also would like to become the new member of the AF.
同时，我们还发起弄了一个叫什么天都国际深空探测这个会议，这个已经发起开到2次了。今年我们9月份将召开第3次天都深空探测国际会议。为什么叫天都呢？因为中国最好的山是黄山，黄山里面最雄伟、最壮观。黄山里面最高的山峰叫天都峰，所以我们就把这个国际会议的名字啊命名为天都会议。
To study all of the related questions, we also have hold of the new international deep space conference. It's called the Tiandu Forum. We already have held 2 such of Tiandu Forum in the past 2 years, and this year will be in the beginning of September. We will have a third of the Tiandu Forum will be held in China. So why we call this Tiandu? The Tiandu in Chinese means the space capital, because it's the Tiandu. This is a peak of the mountain, as also the most beautiful, the mountain of the Yellow Mountain, the Huangshan. So it's Christian have visited last year. So this is well, we wish that it will be. Everybody could have to pick of this is a peak of the Huangshan Mountain of the deep space. Thank you.
所以我们构建了这么2个学术交流的平台，我们希望在座的专家或在座的我们这个听众啊，都能够到黄山也看一看，游一游。谢谢。
So we have built such two of the international cooperation platform. One is the International Deep Space Association. Another is the International Deep Space Conference, the Tiandu Forum. We welcome everybody to come to China to participate, and we will go together to study the International Lunar Research Station. Thank you.
Well, thank you very much. And we are just running out of time, so we do not have time for questions from the audience, but a lot of questions were towards international cooperation, which you have expanded very intensively already. I would like to ask you to give a round of applause to our distinguished speakers. I think this was an outstanding start of this conference.